Hello everyone, welcome to the IIS Open Campus. My name is Janak Prasad Kharel and I am Master's Second Year student at the Oguchi Lab. My research is related to the study of impact of weather conditions on motorway network performance. Let's start with introduction. Weather conditions have a significant impact on the traffic flow parameters such as free flow speed, capacity, and density, as the rainfall affects on visibility, road surface conditions, and drivers' behaviors. Fundamentally, traffic flow can be defined as the function of velocity and density at a given condition. However, under the impact of rainfall, it is further influenced by different conditions created at the same location. The figure shows the flow density curve of the severe line outbound. It is clearly seen that maximum flow rate under the impact of rainfall is less than that of under the normal condition. Further, the congestion situations occurs relatively at lower density than in normal conditions. When the demand flow rate at a section exceeds its capacity level, breakdown of flow occurs, and a queue of the vehicle starts in the upstream. Such breakdown may occur even at a lower flow rate under the influence of poor weather conditions. So, the objective of my research is to evaluate the impact of weather conditions on motorway network performance by evaluating the bottleneck capacity and departure flow rate under the influence of rainfall. Now, let's talk about how I am proceeding my research. I have used two datasets, traffic data and weather data. Traffic data is obtained from MAX detector, which is 5-minute aggregated data for each detector as well as average at a sectional level. For weather data, I am using MADAS data, which is the data recorded at the meteorological stations and hourly data is available. To improve the accuracy of the weather data, I am also using the radar data, which is available at the grid size of 250 meters, and I am considering to use 5-minute aggregated data to match with 5-minute average traffic flow data. I have listed the sections which are identified as the major bottleneck sections of the Metropolitan Expressway network. And from the 5-minute aggregated traffic flow data recorded by the detector, the congestion events are identified when there is flow level of R or Y observed continuously for 20 minutes. The breakdown time is considered when the velocity first drops to level R or Y. Now, let's discuss on the preliminary result. The rainfall affects the traffic flow by two ways. First is due to the intensity of the rainfall at the time of driving, and second is due to the surface conditions of the roadway as a result of continuous rainfall. As seen in the graph first, plotted for the breakdown flow rate and rainfall intensity, the breakdown flow rate reduced as the intensity of rainfall increased. The congestion event began at a lower flow rate than in normal conditions at a section. The second graph is plotted considering continuity of the rainfall from 60 minutes before the breakdown occurs. It is observed that breakdown flow rate decreases as the surface condition becomes more wet. The breakdown of the flow occurred at a lower flow rate when the rainfall continued and increased from the conditions at 60 minutes before. To summarize, the poor weather conditions further reduces the capacity of the bottleneck sections, causing higher chance of breakdown of flow even at a lower flow rate. Such reduced performance of the sections may further impact to the whole motorway network performance. In addition, a large variation of breakdown flow rate was observed even at the normal condition. Hence, other variables are also important to be considered. And the evaluation of surface conditions may need a careful considerations of other weather parameters as well. That's all about my presentation today. Thank you very much for listening. Thank you.